So now we're going to start section 14.2, which is about double integrals and volume. So let's start by talking about volume of a solid region. If your function f is integrable over a plane region R, and your function f of xy is not negative for all x, y, and r, then the volume of the solid region that lies above R and below the graph of f is V. It's the double integral over R of f of your function f of xy, and I'll write dA here because it could either be dy dx or dx dy. So this tells me how to get the volume of this solid. Now before we do some calculation problems, we first want to talk about the properties of double integrals. So here C is a constant and F and G are continuous on the region R. So the first property says if I have a double integral over my region of a constant times a function, I can pull that constant out, C times my double integral. A lot of these properties are just going to be similar to properties you saw for single integrals. The double integral of a sum or difference you can split up into the double integral over f plus or minus the double integral over g Our third property is that the double integral is greater than or equal to 0, provided that your function is greater than or equal to 0. Our fourth property is that the double integral over f, say dA, is greater than or equal to the double integral over R of my function g if the function f of xy is greater than or equal to g of xy. And the final property is number 5 here, the integral over my region R it's equal to the sum of the integral over the region R1 plus the double integral over the region R2, where R is the union of two non-overlapping subregions R1 and R2. So this last property is kind of the analog of the the version for a single integral where you had like the integral from a to b plus the integral from b to c is equal to the integral from a to c. But now we're not working with just intervals, we're working with regions, and so you just break your region R into two subregions, and you require that those two subregions don't overlap.